Welcome back, Math 10. Today we are going to look at rational exponents. Now I look at it, what does rational mean? Well, a rational number is a fraction, anything that can be put into fraction. So we're going to be looking at exponents that can be put into fraction form. So in other words, we know integer exponents, we know integral exponents and stuff like that, and whole number exponents. So now we're going to be looking at fractional exponents. Well, let's take a look at this first part here. We have square root of 5 multiplied by the square root of 5. Well, we just multiply the bracket, square root of 25. That's going to give me the same as square root of 25 is 5. Okay? Let's take a look at my next one. While we do this, well, that's adding the fractions together. So that's going to give me to the power of 1, which is just the same as 5. Alright? Now, complete and evaluate the following here. Alright, so we have 2 square root, cube root, all the same radical. Okay, the index is the same, so let's multiply all the radicals together and we want to get 8. Cube root of 8 is 2. That's interesting. Now, let's take a look at the next one. It says 2 to the power of 1 over 3, 2 to the power of 1 over 3, and 2 to the power of 1 over 3. That is the same as, if we multiply them, that's the product rule, so we must add them. 1 over 3, 1 over 3, 1 over 3, which gives me 3 over 3, which is the same thing as 2 to the power of 1, which is 2. Okay? Now let's continue this here. And look, it says deduce the meaning for 1/3. Now look at this. 2 to the 1 over 3 and 2 to the cube root. There's a relation there, isn't there? These are the same, that gives me 2. These are the same, that gives me 2. What about 5 to the 1/2? How are those related? Probably figured it out. Okay? Well, now we want to write the following in radical form. So we're going to put this into radical form and evaluate mentally. Alright, so this is the same as square root of 25. Well, I know the square root of 25. It's just going to be 5. 5 multiplied by 5. This one here wants the cube root of 64. So what number multiplied by itself 3 times is 64? Well, 4 times 4 is 16. Multiplied by 4 is 64. So I'm going to have 4. Last one is 81. Well, we want the fourth root of 81. So what number multiplied by itself 4 times gives me 81? Well, 3 times 3 is 9. Multiplied by 3 is 27. Multiplied by 3 is 81. So 3. Simple. Now, write the following in radical form. So we have algebra. This is just going to be square root of x. This here is going to be the cubed root of b. This one here is going to be the 10th root of p. And this last one here is going to be the nth root of a. That's it. So, fractions, if it's 1 over something, that's the same thing as the nth root. 1 over n, the nth root. Look how this and this relate. Okay? Now, investigate the meaning of m over n. So when it's not a 1. Well, I have 5 to the cube multiplied by 5 to the cube. Well, that's this multiplied by this. So it's the square root of 5 to the cube multiplied by 5 to the cube. It's just going to give me 5 cubed, because it's the same thing automatically, which is 125. Okay? Let's try this next one here. We want fifth root, so we're going to add these. So that's 3 over 2 plus 3 over 2. Well, I add those together, that gives me 6 over 2, which is 5 to the power of 3, which is the same as 25. Huh. Well, how are these related to this? It's kind of interesting. Complete the next one. We have 2 squared, cube root of 2 squared, cube root of 2 squared, cube root of 2 squared. Product law. Multiply them all together, so I can multiply my radicals together. That's going to give me the cube root of 2 to the power of, well, we'll add those together, 2 to the power of 6. Or if I put that in my calculator, what's that going to give me? 2 to the power of 2, which is going to be 2 squared, which is equal to 4. Okay? Now let's look at this here. We add this 2 over 3, 2 over 3, 2 over 3. Well, add those all together and we're going to get 6 over 3, which is equal to 2 to the 2 squared. 6 divided by 3 is 2, which is equal to 4. So these are the same thing. So what can we figure out between this and this? So eventually you should have made a rule by now and see the patterns occurring. So This is the same thing as the third root of x to the power of 5. Okay? The next one here is the same as the fifth root of b to the power of 4. So this is always what the number is to the power of. If I look, we have 2 there, the 2 goes there. The denominator still goes outside, just like over here. The denominator goes outside. If it's anything other than 1, the denominator there went outside. If it's anything other than 1, we're going to put that there. So here we have p, 5 over 2 is p square root. We put imaginary 2 if we want, all to the fifth, power of 5. Okay, so this is a, we want the nth root, all to the power of m. Now this next part here I'm not going to do, but I strongly suggest you look at this investigation here and the next investigation as well. Okay? So let's go on to our first class example. It wants us to look at 25 to the power of 3 over 2. How do we look at this? Look at it. We have 25, same thing as saying 25 square root of 3. Well, what is easier, taking the square root of something or cubing it? Square root of this one would be easier. So I'm going to square root that. That's going to give me 5 cubed, which is equal to 125. Because this is essentially the same thing as square root of 5, and then we cube, or 25, and then we cube that whole number. Okay, square root of 25 is 5, and we cube it. Let's take a look at the next one. So this is 1,000, and we want the cube root, and all to the power of 4. Okay, so first we're going to cube root 1,000, which is the same thing as cube root 1,000, all to the power of 4. So it's going to be 10 to the power of 4, which is equal to. Okay, so normally we do the rooting first, and then we do the exponent. Okay, so we do the denominator first, then the numerator, normally. Okay, let's look at this one here. Well, the first thing I notice is it's negative. That negative means we have to switch it. So this is really the same thing as 1 over 27 to the 2 over 3. Now I could solve this a bit better. This is equivalent to 1 over 27. We have 2 there and a 3 there. Oh, sorry. I have a 3, 2, because numerator, denominator. Now notice when I converted this, I only flipped the base. I did not flip the exponent, only the base. That's a key thing to look at. So now I go over this, and what's the cube root of 27? It's 3. Okay, so that's 1 over 3 squared, which is equal to 1 over 9. All right, now let's take a look at my next one, 16. Well, that's negative, so that's going to be 1 over 16 to the 3 over 4. Once again, this doesn't flip, only the base flips. The exponent doesn't flip when it's negative. Okay, and we look at this now. Okay, it wants me to 4th root 16. So 1 over 4th root of 16, and then we cube it. So the 4th root of 16 is 2. And we want to cube it, which is 1 over 8. That one's done. All right, now we're going to e, negative 8, and we want that to the power of 2 over 3. Okay, so we have to first cube root negative 8. Then we're going to square whatever that number is. What's the cube root of negative 8? That's negative 2. Squared, it's going to give me 4. That's it. Let's try this next one here. Negative 8 to 2 over 3. So that's negative, because remember, there's no brackets here, so that there's a negative 1, we could say, multiplied by 8 to the 2 over 3. So we want negative 1, 8, and the cube root squared. So it's going to give me negative 2 squared, which is negative 4. See how it's different? The negative is not affected by the exponent there. The negative is not part of the base of the exponent. Now let's take a look at this last one. Well, we must follow BEDMAS, so we're going to do our brackets first. Okay, so in the brackets we have 3 squared is 9, plus 4 squared is 16, all to the power of 1 over 2. That's 25 to to the power of 1 over 2, which is square root of 25, which is equal to 5. And we are done. All right, example number 2. Here, we have 9 over 4, and we want to the power of 3 over 2. So first, we have to square root both. So that's 9 to the 3 over 2, and 4 to the 3 over 2. Okay? Now, that's 9, square root of 9 to the power of 3, and square root of 4 to the power of 3. Well, square root of 9 is 3. 3 cubed is 27. Square root of 4 is 2. 2 cubed is 8. There's my answer. Let's take a look at the next one. We have that negative. What does negative mean? We have to flip these. Both of those will be to the negative now, so we're going to flip them. So I'm going to get 4 over 9. Now all of this is to the positive 3 over 2. Good. Okay. So now this is the square root of 4. And that's going to be cubed all over square root of 9 cubed. So once again, 8 over 27. Now in the next one, it wants us to write an equivalent expression for the radicals. So using radicals, let's make an equivalent expression for each one. This first one here is going to be the cubed root of r. The next one here is the 7th root of s to the power of 4. Okay? Let's take a look at my next one. This is going to be, well, 1 over t to the 1 over 6, which is t to the 1 over t square root 6 root of t. I'll make that a little bit neater so you can see it. Okay, now here's my last one. What does this equal to? Well, we must flip it again. So that's 1 over v to the 3 over 2. So it's going to be 1 over, and we have square root of v cubed. That's it. It's the 3. Numerator goes there, denominator goes there, it's imaginary 2. All right, now consider the following powers. Okay, explain why 3 of the above powers can be calculated and the other has no meaning. Well, I look at this one here, we could take the cube root of 64 and then square it. Yeah, that's 4, 16. This one here, I could take the cube root of negative 64, that's negative 4, squared is 16. This one here, I could take the square root of 64 is 8, then I have to cube it, that's going to give me a big number, 64 multiplied by 8. Take a look at this next one. I can't square root a negative number, can I? Because we could cube root a negative number, anything to the power of an odd, we cannot square root. So in this case here, looking at this, cannot square root a negative number. So D has no answer. Okay? Now let's take a look at number 5. A cube has a volume of 60 meters. Write a power which represents the A, which represents the length of a cube. Well, my volume is equal to my length cubed. So then, if I want to try and find my length, what am I going to do? Well, here's another way of doing it. I know it's also the cube root of that, but we have V, volume to the power of 1, is equal to my length cubed. I divide that exponent by 3, I'll divide this exponent by 3. So that's another way of looking at these rational things. So, my volume, 1/3, is equal to my length. That's it. Okay? Or we could say, which is equal to the cubed root of my volume, which is equal to the cubed root of 60, which is my volume. All right? Let's take a look at the next one. Write a power which represents the surface area. Well, surface area is all sides added up, the area of all sides. The area of a square is length times length. Okay, so the length squared multiplied by 6, because there's 6 faces of a cube, right? I'll take a look at this. This is a rectangle, but I have 1, 2, 3, 4, 5, 6. Okay, now a cube would be just a little bit better. So, what is this equal to now? Well, I want to isolate for that L. Or surface, right power for surface area. Well, my length is equal to what? 60. So I'm going to have is equal to 6 multiplied by my length is the cubed root of 60. And we have to square that. Or, this is the same thing as 6 multiplied by my 60 to the power of 2 over 3. Okay? Because I said this length is the same as that, as we found out from here. I just plugged it in. So we have to square that length. So we have all of this squared. So I put that in there. Okay? Now we want to use the calculator to calculate the surface area and the edge length. So first is calculate the edge length. So the length is equal to 60 to the 1 over 3. So I'm going to put that into my trusty calculator. So I have 60 to the power of 1 divided by 3. And I'm going to get 3.91, or 3.9. Now, we want to find my surface area. So I have to go this square. So I'm going to square that. Oops. To the power of 2. And then I must multiply that by 6. See how that works? Which will give me 91.95. Whoops, so 91.0. Carry that over, balance it twice, 92.0. That's meters. There we go. Start to double round. Now, my next question, last question here says, write the number 10 in the following forms. So, as a power with exponent of 1 over 2. Well, we know 10 is equal to x to the 1 over 2. I'm using algebra to help me out here. Well, this is to the power of 1. I want to multiply both sides, we want to solve for x, by 2. So I have 10 to the 2 is equal to x. So then x is equal to 100. X is equal to 100, so we put that back in for x. So I'm going to get 10 is equal to 100 to the 1 over 2. That's one way of looking at it. Okay? Let's take a look at this other one. I'll show you that way again. So I have, and there's other ways of looking at it too, 1 over 3. So 10 is equal to x to the 1 over 3. So something, the third root of something is equal to 10. Well, I want to multiply both sides by 3, the exponents. So I get 10 to the 3 is equal to x. So then 1,000 is equal to x. So then again, now we know what x is, so I'm going to put this in for x, so I get 1,000 to the 1 over 3 is equal to 10. And there's that one. Okay? Well, hopefully you understood everything. If you have any questions, ask me tomorrow, as I'll help you tomorrow as we work on the assignments together. See you tomorrow.